All right, we're looking at section 3.2, factor by grouping. Just a reminder that when we factor something, it means write it as a product. For instance, if I gave you a polynomial like x squared plus 5x plus 6, and later on we will actually learn how to do this. If I asked you to factor that, if we figure out that we can write it as x plus 3 times x plus 6, then we have factored the polynomial. So we've written it as a product. This is multiplication, a product. Okay. More recently, we were doing things like 2x minus 4 and factoring the GCF out of those. So when I look for the GCF of that, I find out that it's 2. I take that GCF, I pull it out front, and I make it 2 times whatever remains when I divide each term by a 2. So 2x divided by 2 is x. 4 divided by 2 is 2. And I have factored the polynomial by factoring out the GCF. Okay? We're going to factor polynomials that have 4 terms today. 4 terms. And we're going to do factoring by grouping. And we're also going to use a box method that will get us the same answers. It just works through it a little differently. So notice that the first step is to factor out any common factors that all 4 terms have. All 4 terms. Okay? Factor out any common factors from all 4 terms. For the box method, it's the same first step. Factor out any GCF from all 4 of the terms. It has to come out of all 4. So that's actually always the first step of factoring, is factor out your GCF. Look for it. If there's a GCF other than 1, you factor it out. Okay, I'm just going to jump into the examples, and I will go through the steps for each process in some of these examples. So the first one, I'm going to use the grouping method. Doesn't look like we put any instructions here, but what we're going to do is we're going to factor each polynomial. Those are our instructions. We're going to factor each of the polynomials that we're given. Notice this one's in standard form. Powers are 3, 2, 1, none. So we've got it written in standard form, which is nice. We're going to look for a GCF. Look at all 4 of the terms, x to the third, 4x squared, 3x, and 12. GCF is just a 1. So there's no GCF to factor out. What I'm then going to do is move to step 2 of the process. So look at the first one, factoring by grouping. Second step says look at or group. So I'm actually going to physically group them with parentheses. So I'm going to group the first 2, and then I'm going to group the last 2. Okay? Group them separately with 2 different sets of parentheses. Next step, step 3, factor out the GCF from the first 2 terms. So I need to look for the GCF for these first 2 terms. That GCF is, look at the terms, x cubed and 3x squared. They have an x squared in common. X squared in common. So I'm going to take that GCF and I'm going to factor it out. So from the first term, if I divide out an x squared, I have an x left. X squared times x is x to the third. If I take the second term, the 4x squared, and I divide out the x squared, I'm left with a 4. Now I do the same thing with the second group. Notice it says then do the same for the second 2 terms. So I look for the GCF, which is a 3. I take that GCF and write it out in front of a set of parentheses, and inside the set of parentheses, I look at what remains when I divide out the 3. 3x divided by 3 is just x. So moving that factor of 3 out in front, so there has to be an x left. 12 divided by 3 is 4, so I now have that. Okay, now, step 4. You should have the same thing left in both sets of parentheses. Notice what I have, x minus 4 and x minus 4. We're going to call that the common binomial. They have that binomial factor in common. I'm going to take that common binomial factor, and in step 5, I'm going to factor it out. So I'm going to take the x minus 4, pull it out in front as a common factor, in this case, the greatest common factor, pulling out the x minus 4, and then inside the second set of parentheses, I should have my GCFs that I identified. Okay, so the first set of parentheses, I have my common binomial. And in the second set of parentheses, I have the GCFs that I found in my groups. And that is our answer. We've taken the original polynomial, we have written it as a product. I want you to think about checking your answers. You can multiply this back together to check your answer. X times x squared, the x times the x squared creates x to the third. Then x times the 3 gets me a 3x. I have a negative 4x squared, and I have a negative 12. It works. Okay, this one I'm going to do with the box method. Okay, first thing I'm going to do is I'm going to look for the GCF. Notice the 4 terms, MP, MQ, NP, NQ. The GCF for those 4 terms is a 1. So no GCF to factor out. So I'm going to jump to step 2. Make sure the polynomial is in standard form. Well, we don't really do standard form so much when we have more than one variable. So we're just going to leave it in the order that it's given. Usually you don't want to switch it around unless there's no other way to do it. So my next step says to draw a 2x2 box. 2 rows, 2 columns. So I've drawn my 2x2 box. I'm going to take the first term of the polynomial and set it inside the first square in the box. So there's MP. All right, the last term gets the last square. That's my NQ. And I'm just going to usually fill them in order. Top row first. So MP, then MQ, then NP, and then NQ. First term gets the first square, last term gets the last square, and the other two, I can switch them around. It doesn't really matter, but I'm going to be consistent, and if I'm consistent in the process, I'll be more likely to remember. That one's an N. Okay, so now what we're going to do, and this is a P, make sure that looks like a P. So now what I need to do, let me look at the next step. It says, look at each row and column separately. So in this top row, I'm going to look for the GCF. Greatest common factor for MP and MQ is an M. So I'm going to put that out here. It says factor it out. We're going to write it outside the box because our factors are going to be outside the box. We're undoing the multiplication. For the second row, NP and NQ have an N in common. So there's that GCF. Then I'm going to do the same thing with the columns. Let me change colors here really quick. Okay, and let's try this. Now I'm going to do this column. So MP and NP have a P in common. And then the last column, the MQ and the NQ have a Q in common. I'm going to switch back right here. What I now have is my factored form. What I can do, the top expressions, the P and the Q, one of my factors is P plus Q, and the other factor is along the other side, right over here, M plus N. And we are done with the problem. And you can check your answer. Check it by multiplying it back out. M times P is MP. M times Q is MQ. Remember, this is a multiplication table. P times N is NP, and Q times N is NQ. It works. Okay, we're going to do example 3. This is the answer I was looking for, right there. Example 3. Look for a GCF. Look at the 4 terms. Do they have a GCF other than 1? The answer is no. So I'm going to group them. So the polynomial that I have is going to equal, I'm going to group the first 2, and I'm going to group the second 2. But now you have to be really careful when that middle sign is a negative. See that negative right there? I'm going to change that to plus a negative. Subtracting is the same as adding the opposite. So I'm going to change it to a subtraction sign, or an addition. Addition, adding a negative. I'm going to put the negative that's in front of the 6y inside the parentheses with the 6y. We'll make fewer mistakes, I think, if we do it this way. So notice if I remove the parentheses, it would come back to what I have at the start. For my GCF of the first two terms, I have 2y squared. So I'm going to take that 2y squared, I'm going to pull it out, and if I divide out a 2y squared from the first term, I still have a 2y. 4y to the third, when I divide by 2y squared, is 2y. When I divide 2y squared by 2y squared, I have a 1. Okay? Now, for my second group, my GCF needs to be a negative because that first coefficient is a negative 6. So I'm not just going to pull out a 3, I'm going to pull out a negative 3. So when I do the GCF, I want the negative of the 3 to come out. So take the GCF out in front, and then negative 6y divided by negative 3 is positive 2y. Negative 3 divided by negative 3 is positive 1. And look at that. I have a common binomial factor, 2y plus 1. See, they both have this factor, 2y plus 1. So what I'm going to do next, in my last step, I'm going to pull that common binomial factor out in front. Factor out the common binomial, so I have 2y plus 1. 2y plus 1. And then inside the other set of parentheses, I should have my GCFs, my 2y squared and my minus 3. And we're done. And you can check by multiplying it back together, you should get back to where you started with. It's not a bad idea to check and make sure that you have the right answer, is it? Okay, example 4. I'm going to do this one with the box. So we did grouping on the last one, now we're going to do the box. Look for a GCF. Oh, look, 5 and 4 don't have any factors in common, and I don't have h's in all of them, so the GCF is a 1. So I'm going to go to the box. I'm going to draw my 2 by 2 box. 2 rows, 2 columns. First term gets the first square, so my 20h to the third power. Second term, negative 16h squared. Third term, and the last term should be in the last square. There's my plus 4. Okay, I'm going to look for the GCF of the top row. So in the top row, I have a 20h to the third and a negative 16h squared. That's these two right here. Okay, 20 and 16 are both divisible by 4. And then h to the third and h squared both have an h squared in them. So 4h squared. Now this second row is a little different. Do you notice that first term in that bottom row is a negative 5h? That first term, you want to think of him as being the general. That first term in that row is like the general. The general controls the sign. It's negative 5h, so I want a negative out here for that GCF, or with that GCF. 5 and 4 are divisible by 1, so my GCF is a 1, but I need the negative. The general, the leader of that, determines the sign that you use. Okay, now let's use the columns. So you have to do this for the rows and the columns, right? So we're going to go with the first column. 20 and 5 are both divisible by 5. Now that's a positive 20, and that general at the top of that column, the general determines the sign. It's positive 20, so it's a positive 5. H to the third and h both have a factor of h. And then I'm going to move on to column number 2. GCF there. Oh, the general has a negative in front, so we put a negative here. 16 and 4 are both divisible by 4, and we do not have an h in common. Okay, so we now have our factorization. We just need to write it out. One of the factors is on the top of the box, and the other factor, let me write that a little better. So one of the factors is on the top of the box. Check your multiplication. Does it work? 5h minus 4. And then the other factor is on the side, 4h squared minus 1. And we are done. I'm going to double check my multiplication. 5h times 4h squared is 20h to the third. Negative 4 times 4h squared is negative 16h squared. I'm just looking at the box. 5h times negative 1 is negative 5h, and negative 4, right here, negative 4 times negative 1 is positive 4. It works. We've got the factorization. Okay. Example number 5. First thing I'm going to do is I'm going to look at all 4 terms and find a GCF if they have one. 6, 2, 36, and 12. All those are even, so I at least have a 2. Do I have more than a 2? No. 2q squared r only has a 2 in it. Not everybody has a q. Not everybody has an r, so the GCF is a 2. So first thing I'm going to do is I'm going to take that GCF and I'm going to pull it out of all 4 of the terms. Remember what it said? GCF has to come out of all 4 of the terms. So 6q to the third divided by 2 is going to leave me with 3q to the third. Second term, I'm dividing out the 2, so that leaves the q squared and the r. Third term, negative 36 divided by 2 is negative 18, but there's a q with it. And then the last term, negative 12 divided by 2 is negative 6, but there's an r with that one. Okay, so we have divided out or factored out the GCF. And now we're going to do this one with the box. But I'm only going to do the box on this polynomial. I don't want to do the box on the original polynomial. I want to do the box after I've factored out the GCF. So I'm going to draw the box. A 2 by 2 box because there are 4 terms. Each term gets a square in the box. So I'm going to do 3q to the third power. I'm going to do q squared and r. I'm going to do negative 18q. Consistency is good. We remember the processes if we're consistent. And the last term, negative 6r, gets the last square. Okay, now I look for the GCF of each row and column. So top row, GCF is going to be a q squared. 3q to the third and q squared r. They both have a factor of q squared. Bottom row, this negative 18q and this negative 6r. The negative 18 says I need a negative out here. 18 and 6 are both divisible by 6. So GCF is a 6. Q and R, nope, different variables. All right, so then I do the first column, this column right here. 3q to the third and negative 18q. That's going to be a 3q. And then finally the last column. Looks like we have an r in common. So when we write out our final answer, now be careful, you don't just do 3q plus r times q squared minus 6. I have to remember that I factored out a 2, and that 2 has to be part of my final answer. So I have 2 times 3q plus r times q squared minus 6, and that is the answer that I would type in if this were a computer question. And we're done.